Hello everyone, my name is Sarah, and today I'll be explaining the real-world periodic function mid-unit assignment. So, for this assignment, I decided to choose a clock as the object that best represents the periodic function. I've chosen a clock because it does not stop, so it will always be completing one full cycle or one revolution. It is periodic as it repeats every 60 minutes. The minute hands are periodic since they're always oscillating to its original position, and the cycle repeats. As the assignment stated, a clock has three hands: the hour hand, which shows 12 hours, the minute hand, which displays 60 minutes, and the second hand showing 60 seconds. So, I've shown 4 photos of the clock with 4 different times and 4 different displacement times. So the displacement, I found it by using a ruler to measure how much it is in centimeters. So for the first clock, we can see that it took 0 minutes and 0 centimeters to measure. This is also our starting point. The second clock took 15 minutes from here to here, from 12 to 3, and this is 12 centimeters when measured by a ruler. And then for the third clock, it took 30 minutes to go from here all the way to here, so 12 to 6, and this is 24 centimeters. And then finally for the last one, in order to go all the way from 12 till 9, that is 45 minutes, and it is 12 centimeters from here to here measured. So, for my reference point, I did when t equals 0, my point will begin when the handle is at 12. Establishing a starting point, I would use a ruler to measure the new point from the minute's hand tip to its new position, which is 12 centimeter. The period is 60, since that is the amount of time for the minute's hand to come back to its original position. The reference point is used to track the periodic functions of the clock's hand. So, as we see in this picture, I did period is 2 pi over k, and we know that our period is 60 because that's the amount of time it took for the minute's hand to come back to the original position. So then we got our k, which is pi over 30. Then I found the maximum and minimum values. So for the minimum value, when t equals 30 and displacement is 24 centimeters, the minute hand goes to 6. So if we look back in here, at this third clock, we can see that at 30 minutes, it's 24 centimeters, and this is at 6, so that is the minimum value. As for the maximum value, when the minute hand is 0, the function hasn't started to move yet, and this happens when the hand is at 12. So if we look at the first clock, we can see that in here, it hasn't started yet, so the time is 0 and the displacement is also 0. And this is our starting point, which is our maximum value. Then, our calculation part. So for the calculations, I use the same equation for both sine and cosine, but I just changed the sine and cosine within it. So I used this equation and then this one. And I inputted the period, which is, the k value, which is pi over 30, and then the a value, or the amplitude, which is 12, and we got that by doing max minus min over 2. And then I got the vertical translation, which is our c value, which is max plus min over 2, and we got 12. And I've also shown in here that when we did period over 3, we got 20. And then when we did 5 times period over 6, we got 50. So this is our graph. This is the cosine graph. And I've plotted the points down here, and I substituted in d at 20, and I got 18. So this is what the cosine graph looks like, and then this is what the sine graph looks like. So they pretty much look similar, but the equations are different. If we compare this equation at the top with this equation here. However, if we want to verify the graph, we can use a graphing technology such as Desmos, and it's also possible to input specific values in the graph to verify its accuracy. So finally, For our reflection, in this periodic functions assignment, the most difficult part for me was to model the way the clock's hand is moving, specifically creating the equation for it. Since it's important to make sure that all numbers calculations are accurate, it was difficult to figure out which hand to use for the movement of it. The easiest part for me was that after I understood the clock's motion, it made it easier for me to graph the function. I also found it easy to solve the variables. After I've completed this assignment, it gave me an eye-opening experience on how to use periodic functions in the real world. These periodic functions can be shown and modeled through many everyday life items, such as the pendulum swinging back and forth, the clock, which we just used, and the planets traveling around the sun and rotate on the earth. This was also mentioned in the assignment. I chose a clock to represent my periodic function since it's used to track time regularly for things like meetings, appointments, and events throughout the day. We gain a better understanding in analyzing the patterns and cycles happening in our daily lives. Thank you for listening to my presentation. I hope you guys enjoyed, and I will see you next time.